Okay, we'll look at the homework problems in section 9-5, which dealt with permutations and combinations. The first problem is this. The 8th grade class at a grade school has 10 girls and 15 boys. How many different boy-girl dates can be arranged? Okay, so pretty much we're just going to use the fundamental counting principle here, where we'll simply multiply the 10 girls and the 15 boys together. So if we multiply 10 times 15, you're going to get 150. So in this case here, 150 boy-girl dates can be arranged. Okay. All right, problem number 2. Also another fundamental counting principle problem. A Pizza House offers 5 different salads, 7 different kinds of pizza, and 3 different desserts. How many different 3-course meals can be ordered? Okay, so if we use the fundamental counting principle, we got 5 salads, 7 different kinds of pizza, and 3 different desserts. So 5 times 7 is 35, times 3 will give us 105. So in this case here, there are 105 different meals that can be ordered. Problem number 3. This one is a permutation type problem. How many permutations are there of the letters in the word plants, if all the letters are used without repetition? Okay, so in this case here, without any repetition, there's 6 letters, and then you got 5, 4, 3, 2, and 1. And actually, this represents 6 factorial. If you recall, factorial is always the product of descending integers here in this case here. So if you do 6 times 5 times 4 times 3 times 2 times 1, you would get 720. So here, the number of permutations here for the word plants will be 720. As if all the letters are used without any repetitions. Problem number 4. Okay, problem number 4 is this. How many 5-person committees can be formed out of a class of 16 students? So out of a class of 16 students, how many 5-person committee members can be chosen? Now in this case, I'm looking at this problem, so here order is not going to be important. So here we're going to be using a combination type problem. And we're going to do 16C5. Notice the larger the 2 numbers on the left side, the smaller the 2 is on the right side. Okay, and the formula for that is going to be n factorial times r factorial multiplied by n minus r factorial. Okay. Now the n is the number on the left side, the r is the number on the right side. N in this case is 16, so that'll be 16 factorial divided by r, which is 5 factorial, times n minus r, which is 16 minus 5 factorial. Now we're going to simplify this. We got 16 factorial in the numerator. The denominator is 5 factorial. 16 minus 5 is 11, so you have 11 factorial. Now if I expand this, I'm going to have 16 times 15 times 14 times 13 times 12 times 11, and I'll stop at 11 factorial because I have 11 factorial in the denominator. But I can expand the 5 factorial as 5 times 4 times 3 times 2 times 1, then times 11 factorial. And as you can see, the 11 factorials will divide out. And I can also divide out some numbers in the numerator and the denominator. If I multiply 4 times 3, that's going to give me 12. I can cancel the 4 times 3 with this 12. That 5 goes into that 15 3 times, so this can be divided out, put a 3 up here. The 2 can go into 14 7 times, so I'll divide the 2 out with that 14. That will leave me with a 7 in the numerator. Okay, so the numerator, I have 16 times 3 times 7 times 13, which will give me 4,368. Okay, so here there are 4,368 ways that a 5-person committee can be chosen. Okay, now let's look at the next problem. This one is 2 parts. Assume a class has 25 members. In how many ways can a president, a vice president, and a secretary be selected? Part A, that's part A. Part B, how many committees of 12 people can be chosen? Okay, so in part A, the order is going to be very important here. So this will be a permutation problem, which is NPR. And that formula is always n factorial divided by the quantity n minus r factorial. So in this case here, there are 3 different officers that are going to be chosen out of 25. And n is 25, so it'll be 25, p, and r is 3. Okay, so here in this case, your n is 25, so it'll be 25 factorial divided by n, which is again 25, minus r, which is 3, factorial. Okay, so if I do 25 minus 3, that's 22. So I have 25 factorial times 22 factorial. So 25 factorial would be 25 times 24 times 23, and I'll stop at 22. So it'll be 22 factorial here, because in the denominator I have 22 factorial, and I can divide that out easily. So all I have to do here is just multiply 25 times 24 times 23, which will be 13,800. Okay, so to answer that question, there are 13,800 ways of selecting a president, a vice president, and a secretary. Okay, that's part A. Part B is how many committees of 12 people can be chosen. So part B. Now the order in this case is not important, so we have to use combinations. So this is going to be 25C and then 12. And that formula again, that's n factorial divided by r factorial multiplied by the quantity n minus r factorial. Here n is 25, r is 12. So n is 25, so you have 25 factorial divided by r, which is 12, so that's 12 factorial, times n, which is 25, minus r, which is 12. That quantity is going to be factorial. Well, 25 minus 12 is 13. So the numerator is 25 factorial. The denominator is 12 factorial times 13 factorial. Now, here we're going to have to expand this as 25 times 24 times 23 times 22 times 21 times 20 times 19, 18, 17, 16, 15, 14, 13. So we stop at 13, and that'll be 13 factorial, because notice in the denominator we got 13 factorial. Now the 12 factorial, I have to expand that all the way out to 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. times the 13 factorial. And 13 factorials, those are going to divide out. And in this case here, if you want to, you can multiply all this out in the numerator and then multiply the whole denominator completely and then divide the numerator by the denominator to get your answer. So if I do 25 times 24 times 23 times 22 times 21 times 20 times 19 times 18 times 17 times 16 times 15 times 14, and then I'm going to take that answer and divide that by, in the denominator, 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You're going to get this number, 5,200,300. Okay, now if you wanted to, you could do some dividing out with some numbers that are in the numerator. Like, let's say in this case here, I know that 4 times 3 times 2 times 1 would give me 24. 4 times 3 is 12, times 2 is 24. All that can be divided out with that 24 up here. I also know a 5 can be divided out with a 15. That will give me 3. With a 6, I think a 6 can go into 18 3 times. And then 7 goes into 21 3 times. Then 8 goes into 16 2 times. Let's see. With a 9, notice with this 9, that can go away with this 3 times 3. And then 10 goes into 20 2 times. 11 goes into 22 2 times. And then with the 12, 2 times 2 is 4 times this 3 will give me 12. So if I kept cross out a 2 and a 3, that can be crossed out with the 12. So all that will be gone. So I have 25, 23, a 2, a 19, a 17, and a 14 that I can multiply to get that answer. Okay. Okay. The next problem. There are 19 points in a plane. No 3 of them are on a line. How many straight lines can be drawn if each line is drawn through a pair of points? Okay, so in this case here, the point order is not important, but you know you're going to have to draw a line through a pair of points, which means only 2 points on a line. So this is a combination problem here. So this is going to be 19C2. And then that's going to be equal to n, which is your 19, so it'll be 19 factorial, divided by r, which is 2, so it'll be 2 factorial, and then you got 19 minus 2 in the parentheses. That's going to be factorial. Now here, 19 minus 2 is 17, so you have 19 factorial divided by 2 factorial times 7 factorial, 17 factorial. Okay, now if I expand the 19 factorial as 19 times 18 times 17 factorial, and expand the 2 factorial as 2 times 1, bring over the 17 factorial, you'll see 17 factorials divide out. So now I got 19 times 18 divided by 2, which is 171. So in this case here, for 19 points, there are 171 lines. Right, number 7. And this is the last problem here on this video. Find the number of ways to arrange the letters in statistics. The number of ways to arrange the letters in the word statistics. Okay. Now this one has letters that repeat. The S repeats, the T repeats, and the I repeats. So there's a formula that we have to use here. In this case here we have n factorial divided by R1 factorial times R2 factorial, and this goes on and on up to R sub k factorial. In this case, the n is the number of letters in that word. There are, in this case here, 10 letters in statistics. So that's 10 factorial. And then, in the bottom, in the denominator, we write the factorials for the letters that repeat. In this case, there are three S's in the word statistics. So we use 3 factorial. Also, there are 3 letters in the word statistics, 3 T's in the word statistics, 3 factorial. So here 3 S's means 3 factorial, 3 T's, 3 factorial. Here 2 I's in the word statistics, 2 factorial. Okay. So if we simplify this a bit, that 10 factorial is going to be like 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 factorial. And in the denominator, I'm going to leave a 3 factorial as is. The other 3 factorial will be 3 times 2 times 1. And 2 factorial is 2 times 1. And then we're going to do some dividing out with the 3 factorials here. Now, 3 times 2 is 6 times 1 is 6, so all that's going to be divided out with the 6. 2 times 1 is 2. That can be divided out with this 4, leaving me with the 2 in the numerator. So in this case here, the numerator, I have 10 times 9 times 8 times 7 times 5 times 2, which will give me 50,400. So in this case, there are 50,400 ways to arrange the letters in the word statistics. Okay. And this should be enough to assist you with the homework problems in section 9.5.